All right, OBS is on. Let's see when Twitch decides that aha, we're live. Preview window is working. Let's see how the sound is. That's working. Stream health is okay. Perfect. All right, well, we still got a few minutes until 7 a.m., so I'm going to use this time to sort of get my environment set up, prepare things, and let anybody show up who wants to. All right, so first thing, let's bring in, go to the Learning Rust. All right, where were we? Learning Rust. Okay, so we've got this. We have the Rust book itself. The second edition. And let's see, what else? What else do I care about? Oh yeah, of course, loading this up in the terminal. And finally one, Averus, hi, welcome to the stream. You found me on Twitch. I'm glad you can make it. Okay, what else do I want to do? Oh, so over the weekend, Rust did update. So if I take a look at Rust C, I've got 1.25, and I believe that 1.26 dropped like only a couple of days ago. Avers, I was literally just talking about that. Yes, that's time for doing that. So let's do rust up. If I do -h, we'll get, it's just an update, right? So it's rust up update. Downloading 1.2.1.26. We'll see how code plays with this version. Visual Studio Code was doing okay with the previous ones, then suddenly sort of like, got a little iffy there. At the beginning, but then it got good, and so now we'll see with the new version if all the tooling is like working properly or it needs to be updated or what's going on. Okay, so we're at 1.26 is our current update. We could go to the nightly, which is 1.27, but I'm not quite willing to do that. One thing that I noticed though when I ran the rust up -h command, that does have, you could run rust up doc --book to open the book. So I wanna see what version that is. Oh, interesting. So take a look. It's just a file. So it's on it's loading the book from the local file system, which is, I mean, I suppose it's okay, especially if I'm doing this on my own, or like on an airplane or a bus or something where I don't have good internet. But this could potentially be updated and that book not be updated. Also, did they update the book for that problem that we had? I'm not trying to remember where was the, it was, I cannot remember. I can't remember where we're going to put an issue in with the book, but there was already one there. Oh well. But it is after 7 o'clock, so if you're If you're go ahead and watching, join Avers in the chat. Say hi. We're about to get started. So let's see where we are. So in Learning Rust, we recently Rust updated to version 1.2.6. So we were about to do that, and now we're going to be starting chapter 8.3. Hash maps. And so the idea is that we'll just run through this and begin go through all the cool stuff. So let's go into chapter 8. I think it was about cargo now creating a binary project instead of a library by default. That's exactly what it was. That was in libraries. Modules, probably somewhere in modules. So I wonder if I could find like the word default in here. Oh, there's only 2 words in default, and so it looks like they just removed any reference to what Rust or cargo new does by default. Now they just say use --bind or --lib. All right, I'm okay with that. I think that's fine. Let's go back to chapter 8.3. And we'll begin. Okay, so storing keys with associated values and hash maps. The last of our common collections is the hash map, the type hash map, which looks like it takes a key and a value in turbo-ish style, stores a mapping of keys of type K to values of type V. It does this via a hashing function, which determines how it places these keys and values into memory. Many programming languages support this kind of data structure, but they often use a different name, such as hash, map, object, hash table, or associative array, just to name a few. Yeah, I mean, I've also seen this as dictionary too, I believe. Hash maps are useful when you want to look up data not by using an index, as you can with vectors, but by using a key that can be of any type. For example, in a game, you could keep track of each team's score in a hash map in which each key is a team's name and the values of the team's score. Given a team name, you can retrieve its score. We'll go over the basic API of hash maps in this section, but many more goodies are hiding in the functions defined in hash map by the standard library. As always, check the standard library documentation for more information. Right, because there's always like tons of cool stuff in there. Okay, creating a new hash map. You can create an empty hash map with new and add elements with insert. In listing 820, we're keeping track of the scores of 2 teams whose names are blue and yellow. The blue team starts with 10 points and the yellow team starts with 50. Okay, so they're using standard collections hash map. Let mute scores equals hash map new. And then scores.insert. So then we pass. So does this have to be a string, like a full string capital S, or can it be a stir that you pass in and then it like converts it to a string? Let's find out. Because I do find it interesting that they're passing like a full string in. So we're going to touch. Actually, not touch. I forgot what I'm working with. It's cargo new. And I think, unless they've changed this, but let's find out. This will be hash maps. Yep, it's still binary. So we'll go into hash maps. We'll open up code here. Okay, so let's first of all, I want to see, does this auto bring in hash maps? Because some of the other ones have been brought in automatically. So if I say let well, we can do the same when they have like the yellow team versus the blue team, or the red team versus the blue team. So red equals, and what we had here, oh, it scores, right? It scores equals, and we have to make it mutable because we're changing it, and it's hash map new. So it scores equals hash map new. You are yelling at me. Oh, yes, because I forgot about the semicolon. So it's saying failed to resolve the use of undeclared type or module, so it couldn't find it. So we do need to bring in standard. So use standard collections hash map. Type annotations needed. Okay, so I need to also be able to say, oh, you know what? I need to be able to actually insert these before it lets me do anything, because then it could infer it. So if it's just on its own, it won't work. So if I say scores dot insert, we're going to put in, so what they were doing was something like string from and then we can say like red, the red team, and they've got like 12 points. Oh, and you need to be mutable. Okay, so that's bringing this in. So now if I want to do the exact same thing, so scores dot insert, but instead of like an actual full string, if I just say a stir like blue team, and they have 24 points. So mismatch types, expected structure, standard string, founder reference. Okay, so it definitely like can't take a reference or anything else, and then basically it won't copy that and create its own. So instead, this does need to be something like we could do blue dot to, is it like toString? Yeah, so these all work. And then I'm wondering, can I print out using the debug syntax scores? What will it give me? Okay, so we're gonna do cargo run. Yep, so it gives me exactly what it like would appear like, a hash map with, this looks this kind of looks like JSON with it quoting the key. But all right. Note that we need to first use the hash map from the collections portion of the standard library. Of our 3 common collections, this one is the least often used, so it's not included in the features brought into scope automatically in the prelude. Hash maps also have less support from the standard library. There's no built-in macro to construct them, for example. Just like vectors, hash maps store their data on a heap. This hash map has keys of type string and values of type i32. Like vectors, hash maps are homogeneous. All of the keys must have the same type, and all of the values must have the same type. Another way of constructing a hash map is by using the collect method on a vector of tuples, where each tuple consists of a key and its value. Okay, so if I have just like a bunch of these, a list of these, it'll automatically like sort of put them in. That's nice. The collect method gathers data into a number of collection types, including HashMap. For example, if we add the team names and the initial scores in two separate vectors, we could use the zip method to create a vector of tuples where blue is paired with 10, and so forth. We could then use the collect method to turn that vector of tuples into a hash map as shown in listing 821. This is one of the things that is interesting about Rust is I'm not overly used to a language that has so many features in it that I guess not really features but methods and properties added on to the types so that we can then just use all sorts of cool things like zip. So what do we have here? So teams vector. So we're creating our vector, and it's just a single vector of team names and then another vector of the scores. And what I find interesting is take a look at this. So it's scores colon, so that's saying what type it is. Hash, so type hash map. So is that because zip wouldn't necessarily turn into a hash map, but it might do its own thing? So let's try this. Basically, this is okay, zip takes in initial scores. Okay, so we have teams.iterate, the iterator, the score, then we zip off of that. So this is how we create our hash map on our own. I'm actually going to create this in a function. So function create hash map. Okay, so we have this in here. We can call create hash map. And then the next thing would be use zip to create hash map. Okay, so inside of here, we're going to do the exact same. Well, I guess it's not exactly the same thing. We want to create two different vectors. So if we say let teams equals, and it's going to be the vec macro, and we're going to just say red, blue, and then let scores equals vec, and then the macro of 55 and 23. Then we're gonna zip them through together. So let so I'm gonna call this teams hash. Teams hash is almost curious. So if I don't do that, I wonder what type of data structure it's going to use by default. Okay, so we're going to take our teams.iter, and then we .zip from that. So the teams.iter basically is that, am I correct in thinking it's a generator that every time it calls it, it gives the next index to iterate through? Is that essentially what it's doing? Now inside of zip, we're going to give it the scores iterator, and then we want the .collect at the very end to collect it all into a single data structure. Oh, type annotations needed. So it won't let me do anything at all. It won't let me use it so we can say hash map, and I think it's, so they were doing like this because we don't know what it is. And now it's complaining it doesn't know how to do that. So then we're going to print line, and we'll say using zip. And that will be the team's hash. And this one is just creating hash map. And if we run this, yep. I mean, it's exactly the same thing. It's just, it is interesting that it won't let us run on it like by default at all. Okay, the type annotations hash map, then the turbofish syntax is needed here because it's possible to collect into many different data structures, and Rust doesn't know which you want unless you specify. And it sounds like it's just going to outright refuse to try unless you specify. For the parameters, for the key and value types, however, we use underscores, and Rust can infer the types that the hash map contains based on the types that data in the vectors. I guess if I use the wrong types in there, so I could put the types in and it would be just fine, but this just allows me to be lazy because we're already putting, like, it already knows what the types are. Hash maps and ownership. For types that implement the copy trait, like i32, the values are copied into the hash map. For owned values like string, the values will be moved and a hash map will be the owner of those values as demonstrated in listing 822. Okay, so basically the hash map can take ownership. Right, so if we add like field name, field value, we insert these into here, and now field name and field value are not available to us. At least not in that view. We have to remove them back from the hash map. We weren't able to use the variables field name and field value after they've been moved into the hash map with the call to insert. And it sounds like I'm not, because it told me I can't put a reference in either, so we can't do that. If we insert references to values into the hash map, the values won't be moved into the hash map. The values that the references point to must be valid for at least as long as the okay, wait, it does allow you to do that? I thought for certain, so if we come here to create hash map, we have blue.toString. Let's add a third one in here. So we can do let, we have red, blue, and how about yellow? So yellow equals, and this will be string from yellow. And now we can insert into here. So scores.insert. So if I pass a reference to yellow along with like 22. So it is yelling at me saying I can't pass a reference to it. Let's actually get the compilers. Yeah, mismatch type. Expected structure standard string found reference. Consider removing the borrow yellow. Could I so it's telling me that I can pass in a reference to it, but I can't. The keys all need to be the same type. Oh, right. So I would need to do a reference to all of these. Well, actually, it'll be easier if I just copy this and try it again. So create hash map with references. And okay, so in here we're gonna have our scores as hash map new. Yet yellow equals this. We can copy this. Well, apparently not that way. And this can become red. And then we can do our scores. So I don't want string from either. I want these to be and back quote. Yes. Multi-cursor for the win. Okay, so we have yellow and red there. We're just going to scores.insert yellow, like a random number, and scores.insert red and random number. Creating hash maps with references. Yeah, that looks like it works. So if we run this, then yep. So yeah, you're definitely right, Avarice. They need to be all the same exact type, which means they need to be references or not references. So we're either going to be moving things into them or completely not moving things into them. At least with the keys, the values is going to be the same thing. My guess is because it's the same type system. So that is definitely something that's nice to know. Accessing values in a hash map. We can get a value out of the hash map by providing its key to the get method, as shown in listing 823. Use standard collections hash map. Let mute scores equals hash map new. We insert these scores. Let team name equals string from blue. Okay, so it's the same type as up here. Let score equals scores.get reference team name. Okay, that's interesting. So I'm guessing we can just use these right here. So instead of creating hash map, and let's also do let red score equals, so it's because it's an actual string that I put in here, I'm going to have to do the same thing. So I'm going to have to say scores dot get, but they passed in a reference to it, which I thought was really interesting. I wonder if I have to do the same thing, or if I can say something like red, like that, and then print line the red score is red score. Nope, it seems. Oh, interesting. Standard option. Oh, it's an option. Oh, interesting. So I could. Isn't there like a dot extract? No, it was something else. It was. Okay, so I think I can do this, right? Yeah, so it's an option out. So it's a it's not, it's an enum. the red score is sum 12. So that's what I'm getting out of it. And I can't remember the name of the method that allows you to extract that, just really to grab the sum value. But that is actually kind of interesting. What if I pass it a full string? Does it yell at me? So if I say .to string, oh, it's right, it's unwrap. Right, which of course throws a full error if there wasn't anything in there, but we happen to know there is because of what we did. And expected reference found structure. So these are full strings in here, but it wanted a reference to another string. So that is, so this cannot be a string, but must be a reference. All right. Here, score will have the value that's associated with the blue team, and the result will be sum reference 10. The result is wrapped in sum because get returns an option option V. If there's no value for that key in the hash map, get will return none. The program will need to handle the option in one of the ways we covered in chapter 6. By, of course, like the let, what is it? The if let. If we can iterate over each key value pair in a hash map in a similar, we can iterate over each key value pair in a hash map in a similar manner as we do with vectors using a for loop. But in this one, we can get key and value. So for key and value in scores. So let's choose, we did this one here, which is getting it out. We can do this one here. So we can say for, we're going to get key and value in the scores. And then we should be able to print them out, right? So print line for loop key and value. And this is going to be the key value. Well, no red line, so let's see if that works. Yep, so exactly as I expected. What's interesting to me is that these are not, it doesn't use options for these. And I guess that's because it can't, we're just iterating over the things that actually are there. It's not going to give us any nones, if that makes sense. Okay, so it'll print each pair in an arbitrary order. Updating the hash map. Although the number of keys and values is growable, each key can only have one value associated with it at a time. When you want to change the data in a hash map, you have to decide how to handle the case when a key already has a value assigned. You could replace the old value with the new value, completely disregarding the old value. You could keep the old value and ignore the new value, only adding the new value if the key doesn't already have a value. Or you could combine the old value and the new value. Okay, that was too much repeating the same words all in one or two sentences. Okay, when we want to change the data hash map, you have to decide how to handle the case when a key already has a value assigned. We could replace it. Okay, we could replace or keep. or combine them. Interesting. Overwriting. If we insert a key and value into a hash map and then insert that same key with a different value, the value associated with that key will be replaced, even though the code. Okay, so inserting same key will just replace it. Even though the code calls insert twice, the hash map will only contain one key value because we're inserting the value for the blue team's key both times. So in here, for example, after we use zip, we now know that we have red and blue. So now if I say teams hash dot insert, so it looks to me like these are going to be references. So if I'm going to say red again, and this time instead of 55, it's 12. Oh, expected reference to string. And this one is expected. Is that reference to integer? Can I actually do that? Cannot borrow mutable. Oh, right. I can do this as a mute. Okay, so now we can do another print. And now red has been updated. And this is the team's hash. Yep, so I mean, kind of exactly what we thought it would be. I think the most interesting thing here is that we had to have the reference. So when we use the zip method here, it's passing in references for everything. So after using zip, now we need everything to be a reference. And I put that on the wrong line. And I accidentally killed my thing. Okay, so after using zip, now we need references. Try replacing the .iter calls with into iter. All right, let's try that. So this is into iter. Then expected integral value found integer. So if I remove this, what's interesting though is this is not, the string is still happy. And if I remove this, it's still happy, yay. Okay, so after using .iter, we would need references. Into iter does not need references. So is into iter actually moving it instead of creating a I think that must be what it's doing, right? Oh, nice. Is this, I don't actually know if this is new or not. Conversion into an iterator with, I'm not sure I like the fact that it links me to a nightly version of the documents. But yeah, that's nice. Into iter takes ownership, so that's nice. So I can just replace that with takes ownership. That is actually really nice to know for when I need to do that. And like, it makes sense for me to like, here, you can own it. I don't care about it anymore. I want you to own it. All right, let's come back over to the book. Okay, so we overwrote a value. Only inserting a value if the key has no value. It's common to check whether a particular key has a value, and if it doesn't, insert a value for it. Hash maps have a special API for this called entry that takes the key you want to check as a parameter. The return value of entry function is an enum called entry that represents a value that might or might not exist. Let's say we want to check whether the key for the yellow team has a value associated with it. If it doesn't, we want to insert the value 50, and the same for the blue team. Using the entry API, the code would look like this. Okay, so we're creating a good old strings here. So then scores.entry, we pass it in the key dot or insert. So this returns an enum. This returns an enum, and then we're able to use that. Now I can't remember, is with Node, is it dot syntax, basically the return value of this, we then get a chance to run methods off of it. And that's how we can chain things together. That's how it works with many other languages. What it seems like it's doing right here. So, or insert. I love how it's like, well, we'll just find a team and insert this into there. So that's nice. Let's try this. So entry. We'll come back. Yes, the or insert method is implemented on entry. So we get the return value, which is entry, and then we get the or insert. So here's our hash map that we created. Scores.insert. And then we can say scores.entry yellow. And then we can pass it in 50. Dot or insert. So or insert 50. Value used here. Oh, because we moved it in here. I totally forgot that we're using moves in this one. String from, okay, let's not use, we're just gonna have to use yellow. I'm gonna have to, I have to do a .toString. And then of course, the final one is that we can do the exact same thing. So scores.entry, and we can do like magenta .toString dot or insert 55. All right, so that should, like, yellow should still be 22 and magenta should be 55 now in there. Yep, exactly. So it did what we expected there to do. So now what we want is this to say, if yellow exists, do nothing, otherwise do nothing. If magenta does not exist, add it and set to 55. So hopefully like when reading back through this, we'll see like, hey, these are exactly the same lines. We'll see what it's doing fully here. Okay, let's continue on. The OR insert method on entry is defined to return a mutable reference to the value for the corresponding entry key, if that key exists. And if not, inserts the parameter as the new value for this key and returns a mutable reference to the new value. Oh, it returns a mutable reference to the new value. This technique is much cleaner than writing the logic ourselves, and in addition, plays more nicely with the borrow checker. Running the code in listing 825 will print yellow 50, blue 10. The first call to entry will insert the key from the yellow team with the value 50 because the yellow team doesn't have a value already. The second call to entry will not change the hash map because the blue team already has the value 10. Updating the value based on the old value. Another common use case for hash maps is to look up a key's value and then update it based on the old value. For instance, listing 826 shows code that counts how many times each word appears in some text. We use a hash map with the words as keys and increment the value to keep track of how many times we've seen that word. If it's the first time we've seen a word, we'll first insert the value 0. Okay, so we use hash map, that text. So we just have our text we're going to iterate through, I'm guessing. That mutable map, so our new hash map. For word in the text dot split by white space. Now that's a fun method. Let count equals map.entry word or insert. So if it's the first time we see it, 0. But that map entry gives us, it gives us a mutable reference to it. So that's how we can do this. So that's kind of cool. I kind of like doing this one. So let's try that. We're doing it based upon white space. We're doing words. So let's do it's not really iterating through a hash map, is it? It's sort of collecting data, collecting words from string. Okay, function, collecting words from string. So we'll begin with our string. What I find interesting is that they're using just a str for this and not a string for this. And it's been long enough. Well, let's see what happens if I do this. If I say let my string equals, we can pull theirs out here. Okay, so unused variable, my string. So yep, that's sort of like everything is fine now. Now we want to iterate through, well, we want to create the new hash map, right? So let map, I don't think I have to give it anything yet besides hash map new. Okay, so it will infer once we start throwing things in here. Then we're going to for loop through. So for, I think it's going to be string. So maybe we'll call this word in my string dot. So initially I was thinking like iter. So I wonder if I just print line, what is word? Is it going to be each character? No method iter for type. Okay, so There is no method iter. Let's it was split. Was it split white space? Yeah, it was. So split white space. Okay, still no type annotations, but that's because we haven't added these in. Split white space. Can I do split character? No, I was thinking like that'd be pretty interesting if I was able to infer which one, like just guess which ones based upon the names. We can go take a look at more like later on at the documentation and see what methods are available for us to split off of these. But for right now, we'll split by the white space, which will give us the word. So now we can. There is a general dot split, so I can just use split like that. This function takes one parameter. Okay, so you probably want something like, what am I splitting on? So can I say that? Yeah, it looks like I can. So this will be based upon the word, or I can do it based upon every single character. Okay, so I want to take in here that if we then want, like, we'll get the h in, and we'll throw it into the map here. So we'll say let this is going to be a character or the map. What do I want to call this? They're calling it, oh, they're calling this count. That makes sense. So let count equals, and it's going to be map dot entry, and we're going to pass in the word dot, what was it before? It was or insert 0. But now we can update the count, right? So we can say, well, we have, it's a reference. We have to dereference count plus equals 1. Cannot borrow immutable local variable map. Oh, yes, of course. This has to be mutable. All right, so that seems to be going through, and let's print this off. So print line, and we'll say the characters in the string. And this will be map. Let's try it. Yeah, so this gives us exactly what we wanted. We can see, well, okay, close. There's 2 characters that have absolutely nothing in here. Like these are all what we'd expect. This one I didn't expect. The difference between split and split white space in this case is that the letter splits on anything that is defined as a Unicode white space. Oh, okay. Which is why we get things like this. So I'm guessing like there was, well, so we have 3 spaces. So we should see those. Yes. These ones, I'm not sure exactly what those are. Unless these are the end quotes at the beginning and the end. That must be what it is, because there's 2 of them. That's super interesting. I like it. So we can do some fun things with like well, fun things with this. Let's come back to the book. Okay, the code will print hello 2, hello world 2, hello 1, wonderful 1. The or insert method actually returns a mutable reference. 2, the value for this key. Here we store that mutable reference in the count variable. So in order to assign to that value, we must first dereference count using the asterisk. The mutable reference goes out of scope at the end of the for loop, so all of these changes are safe and allowed by the borrowing rules. Hashing functions. By default, HashMap uses a cryptographically secure hashing function that can provide resistance to denial of service attacks. This is not the fastest hashing algorithm available, but the trade-off for better security that comes with the drop in performance is worth it. If you profile your code and find that the default hash function is too slow for your purposes, you can switch to another function by specifying a different hasher. A hasher is a type that implements the build hasher trait. We'll talk about traits and how to implement them in Chapter 10. You don't necessarily have to implement your own hasher from scratch. Crates.io has libraries shared by other Rust users that provide hashers implementing many common hashing algorithms. And that is the end of 8.3. So it is interesting, like I am used to objects in JavaScript, dictionaries in Python. I feel like this feels like something that I would pull out a lot more often. But I think that's because I've also heard of people referencing hash maps in JavaScript as just objects. But structures in Rust is probably what I'm going to pull out the most often, because that's almost exactly the same thing, except it's not hashed with a cryptographic algorithm. Summary. Vectors, strings, and hash maps will provide a large amount of functionality necessary in programs when you need to store, access, and modify data. Here are some exercises you should now be equipped to solve. All right, they've given us exercises again. Given a list of integers, use a vector and return the mean, the average value median, when sorted, the value in the middle position, and mode, the value that occurs most often. A hash map will be helpful here of the list. Convert strings to Pig Latin. The first consonant of each word is moved to the end of the word, and a is added. So first becomes first fe. Words that start with the vowel have hey added to the end instead. Apple becomes apple hey. Keep in mind the details about UTF-8 encoding. Use a hash map and vectors. Create a text interface to allow a user to add employee names to a department in a company. For example, add Sally to engineering or add Amir to sales. Then let the users retrieve a list of all people in a department or all people in a company by department sorted alphabetically. All right, so I'm going to take all of these because these look great. And we're going to add this in to our README here. So let's update our README. So currently we're done with this. We're done with chapter 8.3. So I'm going to say finite. Well, let's first put these in here. And then at the bottom of this, we'll then also say chapter 9 is what we're on next. Okay, what did I do? I accidentally did a Command S and now it's frozen. Yeah, I somehow froze Vim. I can't get out of this. Command Q. Oh yeah, that worked. That did do it. It was Control Q. Okay, good. Get out of there. All right, so for this one, let's go ahead and update, put everything in we got. So our README, everything in here goes up, and we're gonna say finished chapter 8, learned hash maps. So I am going to send this on up. And for any of you who are watching, who are interested in where this code is living, in case you want to follow along, I have it right here. I'm putting a link to that in the chat. And I'm also going to make sure that in the archive that this video goes onto YouTube, we're going to have a link to this as well. I've been doing this, I've been learning Rust in the mornings at 7 a.m. Mountain Time every single weekday, and I plan on continuing that. So see me tomorrow morning at 7 a.m. where we're not going to be going through the book. We're going to be starting to work on these challenges that we have. I just accidentally refreshed the wrong window. There we go. We're going to be working on these challenges instead, and then once we get those, then we'll go into chapter 9. But if it's anything like the last one, this will probably be the rest of our week. All right. If there's any problems that I've had with any of these, please feel free to create pull requests, create issues off of here, or just go ahead and send me messages. I would love to find out if you're following along with learning Rust with me. Or if you have any suggestions or thoughts or questions about the language or anything else. You can find me on Twitter. I've got that linked below, but I'm Brooks_Patton. And also on YouTube, which I have linked below. I am Brooks Builds there. Anyways, with that, I am done for time to get ready for the day. So I hope that you all have a great day, and I'll see you tomorrow morning.